In this section, we'll be looking at distributions some more and different ways to display distributions of data. We'll start with some vocabulary. The first word we'll look at is a quantitative variable. A quantitative variable is numerical. And so we can think of lots of variables that are numerical in nature. If we were looking at cars, you might look at the miles per gallon. That's a number. You might look at the weight of the car. You might look at the price of the car. All of those things are numbers. A categorical variable is a category. So if we stuck with our idea of looking at cars, the category might be whether it's a sedan or a van or an SUV, so like the body type, or the color of the car. So those are categories, they're not numerical. We've already looked at one way to display distributions, and that's a dot plot. And you may have noticed that dot plots are really useful when we have less than, say, 30 numbers. Once we get a lot of numbers, making a dot plot by hand is tedious, right? We have to make a number line, and then we have to find the data and actually plot it by hand, and it takes some time. When we use a computer, we often make what's called a histogram, and a histogram will group the data, and it's useful when we have more than 30 numbers. So a histogram will do the same type of thing, but you'll see bars instead of dots. And sometimes you'll see two numbers grouped together. So in the notes here, I have a very detailed explanation of how to create a histogram by hand. And in reality, we will be using technology to do this. I just want you to understand how this all works. So here's the set of data. I've got heights in centimeters of 45 high school females. So to make this histogram, first, I'm going to look at the high number and the low number. So the low number in here is 148, and the high number in here is 176. And I would need to figure that out if I were going to do a dot plot as well, because I would need to know how to make my number line. So then what we do is we're going to make groups. And in this case, I'm going to make 6 groups or classes. So class is just another fancy word for group. I'm going to make 6 groups of width 5. And what I've done down here is I've started the group at 0.5 because that way I know where to put a number that falls right in the middle. For example, if I made the endpoint 147 and not 147.5, I wouldn't know which group to put that observation in. So once I figure out my endpoints, and I want you to notice they're all 5 units wide, so 147.5 to 152.5. Then what I do is I go through and I would count how many of each there are. So I would count up how many times do I find a value between 147.5 and 152.5. So like this one, let's see. I know there's 6 in here. I'm missing some. Let's see. 147.5 to 152.5. Maybe you're finding them faster than I am. Oh, there's one. Oh, there's one. There's one. Okay, so there are my 6 numbers that are between 147.5 and 152.5. I would do that for each group, each class. I would count the frequency. The frequency just means the number of times that we get that value. And the relative frequency is the frequency divided by the total. So here, this 0.13, this would simply be 6 divided by the total number of observations, which is my 45 numbers. Okay, so that was kind of a lot. I made these 6 groups, I counted up how many observations were in each group, and then I figured out the relative frequency. Now I'm ready to draw my histogram. So the classes, the class endpoints, which are right here, those go on the x-axis. And then the frequency is the y-axis. I'd like to point out it's pretty easy to convert from relative frequency or from frequency to relative frequency. If I were to take each one of these and divide by 45, that would get me relative frequency if I was interested in that. And then the height of the bar is simply taken off of my table. So here we have a histogram of the data. And when I read this, I can see, like when I look at this first bar, I can see that 6 people fell between 147.5 and 152.5 inches tall. Okay, so that's a histogram. We have one more way that's, actually 2 more ways to represent data. The next one is called a stem plot. A stem and leaf plot it sounds like plants, and it kind of looks like plants if you know what you're looking at. What we do in a stem and leaf plot is we look at the data in terms of its place value. So the left side of this is the tens place, and the right side of this is the ones place. So here what I have is a stem and leaf plot. It's already created, and it's the number of hours worked by the yearbook staff during the month of September. So when I read this, I'm going to use yellow here. When I look at this data point, that 01, that would be somebody that worked 1 hour. And when I see this data point, 02, that's somebody that worked 2 hours. And this would be 05, somebody that worked 5 hours, and then somebody that worked 7 hours. So all of the people in this first row worked less than 10 hours. Then next we see 14 hours, and then 16, and then 18, and then 18, and so on. And we can see that there was one lonely person, perhaps, that worked 67 hours on the yearbook. That person really put in their time. So the tens place on the left-hand side, this is called the stem. And on the right side, the ones place, these are called the leaves. And again, it's a way to represent the distribution. What's kind of cool about this is that if you take it, and I'm going to see if I can take a picture of it. So if I duplicate that, I wanted to duplicate what was underneath there. I guess that's not going to work. If I were to take this and turn it on its side, it would look like a histogram. So we'll have to find a way to show that to you. Here's the same data again, down here at the bottom. Oops. Actually, will this work? There we go. Okay, so when I take this, will it rotate for me? Yes. If I take this and rotate it like that, now it looks like a histogram. I want to be careful when I do that rotation though, because typically we start with 0 on the left side and the bigger numbers on the right hand side. Okay, so this is called a back-to-back stem and leaf plot. And here I've introduced another variable. I've introduced gender, which actually I should update this because we only have girls and boys represented here. But I've got girls on the left and boys on the right, and this is a way for us to compare the distribution of the girls to the distribution of the boys. Again, this is the same data from above, but you'll notice the person that worked 67 hours in this example was a girl because they're on the left side of the stem. Okay, that does it.